and it's hard to keep track of whether the model is actually improving. So what we're going to do is we're going to try and analyse the quality of our current model mathematically, and then try and improve on the quality of that model. So the model we have at the moment is this function f, which we've typed in. I'll just show you over here. So this is the model we have at the moment. Now, I'm going to get the spreadsheet to try and calculate the solution, the answers to the depths for each of these hours using our model. So this was actual real life data. We're going to create another column with our predicted D, and I'll explain what this is in a moment. So I'm going to get the spreadsheet to apply this function, so to read off values not from the points but from the curve. So I'm going to get it to give me the function, which I've got here, of this value. So it's going to tell me, if I use this equation, what should the depth be at 0 hours? And it tells me it should be 16.2. So far so good. So let's try to get it to predict me. If I use this function, which is my model function, at 3 hours, what should the depth be? According to this, the depth should be 17.5. Now the depth in real life was actually 17.49, so already it's a little bit out. And so we can continue, and it gives us what our function predicts at each of those hours. So it's saying, for example, at 27 hours, the depth should be 17.5. Already we can see that here our model is quite far out. But rather than saying, oh, it looks like it's not a very good model, or it looks like it's far out here and there, we're actually going to analyse it mathematically. So we're going to look at the error in each case. So I want to see how far out, what the difference is between my prediction using my formula and the actual value. So I'm going to ask it to give me the difference, which is a subtraction, between the predicted and the actual value. Okay, and I'm going to get it to do that all the way through. Now, I want a picture of the overall quality of the model. I don't want to look in detail at each section. And so one thing I could do is I could take the average of these numbers. And can you see how there could be a problem with that? If I take the average of these numbers, the mean, because some of them are positive and some of them are negative, I could end up with a mean of 0, which is quite misleading, because there could be one value that completely underestimates and one that completely overestimates, and they'd cancel each other out. And even if you had a really bad model, you could still end up with a mean error of 0. So we're actually going to remove that sign, and hopefully you remember that to remove the sign we use the absolute value. So we're going to use the absolute value of the error. Okay, so spreadsheet knows what to do, ABS of this value, and then extend it all the way down. So now I can find the average. Actually, the spreadsheet will do mean. So it equals the mean of all these values. Okay, so it's not a bad model. The average error is 0.54. Now let's for a minute just see what happens if, as we said earlier, we change the B value a little bit. So if we adjusted, if we adjusted the value of B, let's see if it'll let us do it. Yeah, if I change that to 28, keep an eye on this. It used to be 0.54. I'm going to change it to 28, change the B value to 28. And already it's making a massive, massive difference. Really good model we've got there. So that would have been a good idea. Sometimes you'll see that your amplitude maybe isn't high enough and you might want to play with the amplitude. Sometimes you'll think that the central line isn't quite in the right place and you want to play around with that. So what we're trying to do is we're trying to improve the quality of our model by adjusting the values of A, B and C. And we're keeping track of that by looking at the mean. Now when you do your write-up, it's important that you don't just give the final value, look, here's my amazingly accurate formula, but that you actually show the process. So show your mean errors as you went along. Okay, this is a mean error. Okay, and obviously make sure you quote which was the formula that gave you the smallest amount of error, which in this case was the one we had here. Okay, now that was fairly straightforward, but we're just going to do one more thing which could help us, and I only discovered this